Hi everyone, welcome in. Thank you for joining us live. I am Moitrey and I am the team lead of our customer success department here at Apsi Connect. With me today is Manak, our technical lead of CS team, who is going to walk you through the technical side of things.
Hello, everyone.
So let's start with the big question. Claude can build your integration. That's not a hype statement. It's true. LLMs today can genuinely write working integration code, connectors, and API mapping. But the real question is we want to unpack today isn't can AI build it? It's when should it? And when do you still need a dedicated integration platform sitting alongside it? That's what we are here to answer honestly. So, no sales pitch, just a practical breakdown.
Yeah. From a technical standpoint, this is a conversation we are having with a lot of our engineering teams right now. So, AI coding assistants are excellent at generating a script that hits an API, transform a payload, and to push the data into a system. So that part is nowadays resolved, but integration in production is not just does the code run once. So it's always includes the retry mechanism, error handling, schema drift, OAuth token refresh, and the authentication mechanism. So everything is included within a connector. So today we will walk through exactly where AI built custom code can shine and where it quietly turns into the most expensive line item in your architecture. So
So, stick with us, and by the end of this session, you'll walk away knowing exactly where that line is for your stack. So, let's get into it. So here's something we want to be upfront about. When we started planning this session, the plan was simple: show you a platform, walk through a demo, done. That's the webinar we were going to give. But when we actually sat down and look at the questions coming in from customers and prospects, so that was not what people are asking anymore. The old question used to be, here's how AI and a platform build an SAP integration fast. A nice collaborative story. The question we are hearing now is much sharper, much more direct. So it's like, why pay for a platform at all if AI can build it? And honestly, that's a fair question, right? It's a budget question, it's a head count question, it's a architecture question. And honestly, teams are asking it because AI coding tools have gotten good enough that it's no longer a silly thing to ask. So we are not going to dodge it today. We are going to answer it directly.
and also the shift also technically changes. So a year or 2 year ago, if someone said let AI write your SAP connector, so the honest answer was it will get you a rough script, you need to debug it, you need to check the code, and then you have to change it, then you can deploy it. But today any AI model can genuinely produce working authentication flows, IDOC parsing if you are using SAP ECC, RFC calls, retry logic, authentication mechanism, everything. So the question flips from can it write the code to what happen after 6 months when SAP changes an endpoint or any e-commerce changes their authentication mechanism or any marketplace has their new API launches. So that's the really point that we need to dig into. So not AI. So we today we will not talk about that AI versus platform as a competitor, but where each one actually earns its place.
So, why am I paying for a platform? This is the real question now. The kind we hear directly from customers, from prospects evaluating us. Even internally, sometimes, if an AI assistant can write my integration in an afternoon, why am I paying a subscription for an integration platform? And I want to say clearly, this is a legitimate question, not a defensive one. If you are a business leader looking at your budget and you know your dev team could just prompt an AI to build a connector, you should be asking whether that subscription is worth it or not. We'd be asking the same thing if we were in your position. So let's not brush past it. Let's actually sit with it for a second before we answer it.
And basically, technically, this question is actually correct. That what makes it a good question. So, an AI assistant can genuinely nowadays write a working integration in an afternoon with all the authentication, basic transform, a post call, and push the data to the system. So that's within a reach nowadays, and lot of use cases today you can see, and especially for the point to point integration, it can happen in a afternoon. So we were not going to stand here and tell you that AI can't do this, only our platform can. So that would be a like dishonest answer. You would see through it anyway. Instead, what we want to show you next in what afternoon does not include, what happened after that first successful run, what the same integration has to survive contact with production.
Right. So let's answer that question honestly, because the honest answer isn't no always use a platform. There genuinely are situations where the right call is just build it, let AI write it, ship it, move on. The first case is when the integration is peripheral, not core to your business. For example, website leads flowing into your CRM, marketing lease sync, reporting extract someone pulls once a week. If that integration broke tomorrow, nobody in your leadership meeting would even hear about it. And the second is low volume and simple, one source, one destination, a handful of fields, no complicated business rules layered on top. There's no orchestration, no branching logic, nothing that needs to reconcile against multiple system. And the third, and this is really the deciding factor actually, failure is survival. If that integration goes down for a day, nobody stops shipping product, nobody stops invoicing customers, nobody stops selling. Worst case, someone reruns and export manually. In those three situations, spinning up a platform subscription is genuinely overkill. AI built in-house, that's what we want to be honest about it. I mean, that works actually.
Yeah. Right, and from the engineering lens, these three conditions basically describe the integration with almost no failure surface. So low volume means you don't need to throttling or bulk handling logic. Peripheral means there is no SLA riding on uptime, so you don't need to monitoring or alerting system or retry orchestration build in from day one. And survival failure means if the AI written script throws an unheld exception at 2 a.m., so the blast radius is basically zero. So technically, this is the exactly sweet spot where an AI assistant is a great fit, a self-contained script run by cron job or triggered manually that one's engineer can read top to bottom and maintain with their own. You don't need to platform governance, versioning, or connector library or something else need to store and content in this.
Right. So that was the easy end of the spectrum, but now let's flip it, because that moment, that same integration touches your ERP, specifically something like SAP, it's not the same decision anymore. It's not even close. Think about what actually breaks. Order stops reaching SAP, and now the warehouse has nothing to pick. No shipping. I mean, so shipping stops basically. Not shipping is delayed, shipping stops, inventory stops flowing back, so you keep selling stock on your storefront that you no longer actually have, and now you are overselling to real customers. Invoices stop posting, cash collection stalls, and month end close, which finance is already stressed about. So none of these are someone notices tomorrow and reruns a script. These are kind of failures that show up in a leadership meeting, that involve finance, operations, and customer facing teams all at once. So this is genuinely a different class of risk, and it deserves a different class of decision, that one we just talked about on the previous slide. Right, Manak?
Yeah. And also, technically, this is where the AI wrote it is an afternoon story starts fall apart. Not because that AI can't generate the code, but because of everything that afternoon build does not account for. So for SAP integration, let's take an example. For SAP integration, we need to deals with idocs, BAPIs, RFC calls, APIs, batch processing. So a lot of hidden state, right? So what happens when a SAP is in a maintenance window and the call times out? Does your script retry mechanism in your script retry mechanism is present? Or does that order just silently vanish? What happens when the SAP changes any field mapping or any IDOC structure is changes during the support pack update? So does anything maintain in your script or the orders just silently failed down? So who will be responsible for that?
Right. And there's a huge difference between a working integration and a running integration. A working integration means it ran once successfully on your laptop, but a running integration means it's still doing its job correctly 6 months from now at 3 a.m. during your busiest sales day without any babysitting it. And here's the thing, none of what Manak's about to walk you through gets written on one day. Right? Nobody sits down and says, let me build reconciliation logic before they have even built the happy path. All of it gets discovered in production, usually the hard way, usually after something's already gone wrong for a customer, right?
Yeah. So let's go through this one by one as Moitri mentioned, because each of these is a real production incident I am sharing with you, and we will check one. So first one is the logging one. So what did we send? What came back through the output? When and without this? So these are all the question we need to store or we need to log it out, because like if any customer says my order didn't sync, so you are just guessing instead of checking in that case. The second layer is that is monitoring and alerting. So you need to know it failed before the customer tells you. That's the difference between fixing something proactively and fielding an angry support ticket. The third thing is retries and recovery. So it's easy to write a retry loop. It's much harder to write one that does not create the duplicate orders when SAP actually did process the first attempt, but the response just did not come back in time. The next point is elasticity. So your integration has to handle a normal Tuesday or Black Friday sale with the same code. A script that works fine at 10 records an hour can fall over completely at 10,000 records. The next one is important, that is the reconciliation. Proof of the data actually arrived in your system, not just that it left your system. Those are two very different guarantees, and lot of homegrown script only give you the second one. The last one is the audit trails. Who changed that? Which version of the integration logic actually ran on a given day? So when a finance team asks why does the number doesn't match, you need to able to answer what with the evidence. So none of these six things are exotic engineering, they are just work. And that is work, that work is exactly what a platform has already built, tested, and also the version is released in that platform. So what you would be building and debugging yourself is already present in that platform as a production. So at this point, someone always say fair enough, but I will just build all of this in my system. So monitoring, retries, reconciliation that works, and technically you can. So there is nothing on that list that I have mentioned previously is impossible to build in-house. But let be honest about what actually involves. You are not just writing the code once, you are not hosting it. So you have to host it in AWS or any other platform so it can actually scale. You are writing a alerting system or something like in the page duty or Slack, any other app. You are writing and testing reconciliation logic against real cases, which usually means that you don't get it right on the first attempt. and then you are maintaining all of it, patching it, upgrading it, fixing it. When SAP changes something on their end, you end up costing this thing twice, once to build and again every month you have to maintain that cost to keep it alive.
And that's exactly where I want to bring this back to the business side, because this is where the real cost hides. And it's not the AWS bill only. So first, the money stops making sense. Your engineering team take hours to build, monitoring, retry handling, elastic hosting, alerting, reconciliation. That's real cost. But it's the recurring hours to keep all of that working that quietly become the expensive part. A platform subscription is usually a predictable, fairly modest line item, but your engineering calendar is not. That's the line item that actually grows. And the second part would be the bandwidth. The bandwidth stops making sense. Every hour your developers spend maintaining integration, plumbing is an hour. They're not spending on your actual product. You didn't hire your engineering team to become integration specialists, right? You hired them to build the thing that makes your business money. So the real question to ask isn't what does the platform cost us? It is actually what did we not ship this quarter because our best developers were babysitting a retry mechanism instead. So that's the number that should actually worry you. So as a business owner or a decision maker, your focus shifts from making profits at your business to handle integration.
Yes. So, everything we have talked about so far assume ERP like SAP, your CRM, your e-commerce platform, the systems on either end of your integration. So they don't. SAP ships support packs, version upgrade. Salesforce pushes API changes on their own release calendar. Your e-commerce platform can add a new field or deprecate an old API endpoint. None of that is optional, and none of it asks your permission first. So the code your AI assistant wrote in that afternoon, the one that worked perfectly against SAP API, is exited that day. It's not the static asset, it's a snapshot. The system it's talking are moving the targets.
And that changes the math we have been building on this whole session. Up to now, we have been talking about the cost of building and running an integration. But now we have a third cost, the cost of keeping it working as the world around it keeps changing. That's not a one time engineering task anymore, it's an ongoing commitment. Someone on your team now has to track SAP release notes, test against upgrades, and catch breaking changes before they break your business quarter after quarter indefinitely. I mean, that's the part that's easy to miss when you're just looking at can AI write this integration? Because writing it was never really the hard part, but keeping it alive is.
So now let's make this concrete with the real numbers because it's easy to say platform change in the abstract. It's more convincing when you see the scale of it. So let's take an example of Shopify. In the last financial year 2025, they spent about 1.54 billion USD dollar against 11.56 billion $56 billion revenue. So roughly 13% of everything they made went straight back into changing the platform your integration depends on. So that's not a company standing still. So that actually shows up concretely in their API. They see four new API versions yearly, uh, in every quarter, and each of one is supported in a minimum of 12 months before it's deprecated. And this it's not hypothetical. As of April 25, Shopify closed the REST admin API to new apps entirely. And now, if you are planning to build an integration with Shopify, you need to make it or build it with the GraphQL. So here you can see one announcement and every new integration you have to be migrate. So that's the pace we are talking about from one platform in 1 year.
And here's why that number matters to you, not just to engineers, because that 1.54 billion isn't Shopify being wasteful. It's Shopify staying competitive. But every dollar they reinvest into changing their platform is a dollar of change your integration has to absorb, whether it's AI written or platform build. So this isn't a one-time build and forget decision. If you are on RESTful API today, that migration to GraphQL isn't optional anymore for new integration. It's already here. And Shopify is just one of the systems in your stack. Multiply this by however many platforms you are actually connected to, and you start to see why keeping it working is really the job, not building it once.
So let's take another two example. So starting with the Salesforce. So with their latest release, so now Salesforce connected app retires. So usually previously we used to authenticate through by creating the connected app in Salesforce, and now this mechanism is totally deprecated. So if you are planning to build the integration with the Salesforce nowadays, so you have to create the external application, and then you have to change your authentication mechanism from user based authentication to OAuth 2.0 authentication. In the other hand, if you consider the NetSuite as your ERP, then for the NetSuite also they are planning to currently we authenticate NetSuite through token based authentication, but they are also planning to change the authentication mechanism to OAuth 2.0 again. And from 2027 onwards, we need to build any new integration with the OAuth 2 mechanism. And from 2028 they will also stop providing any kind of support for the token based authentication. So here you notice just one thing: the destination is identical in both the apps. OAuth 2.0, two unrelated vendors, two different system, same forced migration.
And here's why this matters for planning, not just for engineering, because these aren't maybe someday changes. They have actual dates attached. Summer 26 for Salesforce and 2027 and 2028 for NetSuite. If you are integrated with either of these today using the old authentication method, this migration is already on your roadmap, whether you have scheduled it or not. And think about what that means if that integration was AI built in an afternoon, quietly running in the background with nobody assigned to watch it. Nobody is tracking Salesforce release notes for you. Nobody is flagging NetSuite's end of support calendar. That integration will simply stop working one day, and the first sign of it will be a broken order flow or a login failure in production, not a heads up in advance. So let's slow down here for a second. This is one single timeline starting from right now to August 2026, running out to the end of 2027. And it's tracking four completely independent vendors, all forcing changes on their own schedules. Shopify shipping a new API version every single quarter. NetSuite closing off new token based integration in 2027. Then pulling support entirely by 2028. Salesforce retiring connected apps in summer 26 and SAP ERP 6.0 mainstream maintenance ending on 31st December 2027. None of these four dates are on your roadmap today. Nobody scheduled them, nobody asked for them. They're just coming on the vendor's timeline, not yours. And here's the line I really want to land on a platform. Each of these migration gets absorbed once by the platform vendor, and then every single customer benefits from that work automatically. In custom AI build code, each of these migration gets absorbed by you individually, manually for every single integration you have ever written that touches that system. You have got five integrations touching Salesforce, that not one migration. That's five.
Exactly. And to make that concrete, when a platform engineering team seeks support for, say, NetSuite or to requirement, they write that once, test it once, and it rolls out to every customer on that platform through a normal update. You don't lift for a finger. If you have got custom built integration instead, someone on your team has to notice each deadline is coming, prioritize the migration against the everything else in the sprint, actually rewrite the authentication layer, test it again NetSuite sandbox environment, then it shipped to the production. And then do the same exercise for the Salesforce. And if you are already connected with Shopify, then you have to do the same thing again for Shopify and for your ERP if you consider SAP as your ERP. So here you can see four clocks ticking independently, and if you have built integration yourselves with all of four systems, so it's now your responsibility to track and fix forever for as long as you want those integration exist.
So to understand on the left, custom integration, the AI built in-house route on the right, an integration platform. Let's walk through what each column actually cost you in practice, not in theory. So with custom integration, you track every vendor change log yourself. Shopify's, Salesforce, NetSuite, SAP's, all of it on your own. You migrate each integration one at a time manually. The cost repeats per integration, per deadline, every single time one of those four clocks we just talked about goes off. And here's the one that worries me most as someone managing a team: the knowledge leaves when the developer goes. So if the person who wrote that integration leaves the company, that institutional knowledge about how it works, why it was built that way, walks out the door with them. With an integration platform, on the other hand, the vendor tracks the change logs for you. That's literally their job, not yours. A connector gets updated once, and every customer on that platform benefits automatically. The cost is the subscription you already budgeted for. So, predictable, not a surprise engineering sprint, right? And critically, the knowledge stays in the platform, not in one person's head.
And I would also underline the last point on both sides because it's the one that bites team hardest in practice. With custom code, when a developer who built an integration moves to a different team or leaves the company, whoever inherits it has to reverse the engineer and their own colleague code before they can even safely touch it. So they have to gun through the exact code what is writing. So like that person need to debug everything. So basically there is no documentation documentation over there, no shared pattern, just tribal knowledge that's now gone. So with the platform connector logic, the auth handling, the retry behavior, the authentication mechanism, all of it standardized and document as a part of the product. Any engineer on your team or even a new hire can pick it up because it follows a consistent pattern they can learn once they reuse everywhere. So that's really the core trade of this slide. And you if you don't want institutional knowledge sitting in your code base or your people heads or in a platform that's built to be handed off and maintained by anyone. Now, this is something a lot of teams don't think about until it's too late. It's not just whether you have integration logic, it's where you put it. So SAP actually has name for this: clean code. The principle is that your ERP should stay as close as standard. Out of the box SAP as possible, no custom integration logic inserted directly into it. And there is a very practical reason for that. If you buy integration code inside the ERP itself or inside your storefront or any e-commerce platform, that code becomes tightly coupled with the specific version and the specific system. The next time SAP ships an upgrade or your like storefront get upgraded with a new version, then the deployed logic is blocks you from moving forward, as you can upgrade cleanly because you would break your own custom code in that process. And even for the marketplaces also, you cannot deploy any kind of changes or any kind of custom thing with your own. So the alternative on this slide is a dedicated integration layer sitting between your sales channel. Like if you are using Shopify market, any marketplaces POS on your ERP, That layered is version, monitor, and portable. It does not live inside the SAP, and it does not live inside your storefront. What any kind of customization they do maintain in the platform itself. So nothing in your main uh, standout SAP or nothing in your standalone uh, ERP system is changes. So the integration layer is not what's standing in the way.
And that's why that matters to the business beyond the technical elegance of it. If your integration logic is scattered and buried inside individual systems, every future project becomes harder than it should be. Want to add a new marketplace? You are potentially touching ERP embedded code again. Want to bring on a new warehouse or a new payment provider? Same problem, repetition. But if that logic lives in one clean dedicated layer, adding the next marketplace, the next warehouse, the next payment provider doesn't mean starting from scratch each time. You're plugging into a layer that's already built for exactly that. So this is really the architectural reason where AI build code lives matters just as much as whether it works, because code embedded inside your ERP or storefront is the code most likely to become the thing blocking your next SAP upgrade, which is a commitment most of you have probably already made. So this is really where everything we have talked about today lands. We have spent this whole session walking through a genuine trade-off: the speed of AI assisted building versus the operational depth of a platform. And the honest answer we want to leave you with isn't pick one. It's you shouldn't have to choose. That's the idea here. So not AI or a platform, AI inside the platform. You keep the speed of describing what you want in plain language and having it built fast. But underneath that speed, you get the operational layer. We spend this entire session talking about that: the monitoring, the retries, the reconciliation, the audit trails, without your team having to build and maintain any of it themselves.
Now let's go through what that actually looks like in practice, because these are not marketing labels, they are specific capabilities. On the AI side, autonomous workflow builder, you describe a process in plain English and the platform builds the actual running workflow behind it, not just a suggestion. SmartCrypt takes natural language instruction and turns them directly into the transformation logic. The mapping and the data shaping work that used to take an engineer hours. And Flow Insight flips that around, point it at existing workflow. Even when you didn't build, it gives you a plain text explanation of what that workflow is actually doing. That alone solves the knowledge works out the door problem we talked about a few slides. On the operational slide, this is the layer that keeps it running long after the AI has finished building it. Auto detect does the proactive anomaly detection with self healing when it genuinely can't fix something itself. It hands off cleanly to a human instead of falling silently. Audit login governance means every AI decisions, every interface, every action is recorded in a searchable. So when finance asks why does not this number match, you have a real answer. And operational built in means monitoring, retries, elasticity, reconciliation. Everything from our earlier slide comes standard. You don't build it, you don't need to maintain it.
Right. And to put some real numbers behind that, this is built on a decade of mid market ERP integration experience. This isn't a brand new idea, it's grounded in what actually breaks in production. 90% of use cases need no code at all, and go live is measured in, let's say, in hours, not weeks. So you get the speed everyone's excited about with AI without inheriting all the operational risk we have spent this whole session walking you through. So let's make everything we have talked about today concrete with one example, walking through it step by step. Picture a Shopify order becoming an SAP sales order that's mapping itself on its own isn't the impressive part anymore. It's we have already established AI, and AI can do that in an afternoon, right? So what actually matters is what happens next, and that's the whole argument. We have been making the entire session about it, right? So nobody buys a platform for the happy path. They buy it for the 30 seconds after the happy path fails, right?
Yeah. Now let's walk through what that actually looks like in four stages. So in the step one, that is build. The Shopify order gets mapped and posted into SAP as a sales order, straightforward, and yes, AI handles this part well. So step two, break. Now picture something going wrong the way it's actually does in production. If it can be a bad tax code, a missing customer record, or a sudden volume spike. Not a hypothetical edge case, the kind of things that happens regularly on live scenarios. Step 3, detect. On a platform, the failure gets caught and alerted on before anyone has to call support. Nobody digging through logs trying to figure out why an order silently didn't sync. Step 4, recover. Safe retry, reconciliation, and a complete audit trail automatically. Not somebody manually rerunning a script at midnight and hoping it does not duplicate the order. So that's the part an afternoon AI build typically does not give you by default. And it's exactly what separates it work once from it survives productions.
So after everything we have discussed today, we don't want to leave you with just a philosophy, but we want to leave you with something you can actually use on Monday morning. Let's say, here are 5 questions to run through the next time someone on your team says, "Let's just have AI build this integration." One is, if this stops for 4 hours, does the business stops? So that is the first question. The second can be, how many systems and how much transactional volume does it touch? A single connection with a trickle of records is a very different animal than something touching 3 systems at real production volume. And the third would be, how often do the connected vendors ship breaking changes? So we showed you real numbers today. Shopify 4 times a year, Salesforce, NetSuite on their own multi-year clocks. So that needs planning, right? And the fourth would be, who is on call at 2 a.m. when it fails, and how do they find out? Not hypothetically. Let's be honest, let's answer it. And the fifth point should be, who owns it when the person who built it leaves? So this is the one people skip past fastest, and it's often the most expensive one to get wrong, right?
And also apart from this, the beauty of this five question is they actually give you a clean decision rule, not just food for thought. If you answer are clustering low across the board, low blast radius, low volume, infrequent vendor changes, low stakes, if it breaks, build it, let AI write it, and move on with your day. That's a completely legitimate outcome of the exercise. But if your answers are clustering high, like high blast radius, multiple system, multiple vendors, and that changes in real cadence, real consequences, like at 2 a.m. if a order failures. So that's your signal to put it on a platform instead. And here the reframe we would leave with you, that's not losing to the platform, that's you getting your engineering time back to spend on what actually differentiates your business instead of an integration plumbing that's every other company on that platform already gets for free.
Right. So, if there's one line to take away from everything we have covered today, it's this: build fast where it's safe, run it on a platform where it's not. That's genuinely it. That's the whole talk in one sentence. We are not here to tell you AI can't build integration. It clearly can, but it's only getting better. We are here to tell you that can it build it was never really the right question. The right question is, what happens after it's built, and that's where the decision actually lives.
And this is not where we are stopping either. Next on the FCI roadmap, we are pushing AI assistant design beyond just the build step into the continuous optimization across build, deploy, monitor, and troubleshoot. So the same intelligence that helps you build fast today is going to keep working for you well after go live, watching and tuning the integration over its whole life cycle, not just the first afternoon.
So, with that, we'd love to open it up to you. Drop your questions in the chat. We are going to go through as many as we can, and honestly, we'd love to hear this too. Where is your integration estate slowing you down right now? Is it a Shopify SAP flow like this or a NetSuite migration? Tell us in the chat. This is exactly the kind of problem we love digging into. And thank you all so much for spending this time with us today. This has been a great session. So, over to the questions.